Hello everyone, welcome to the YouTube channel of ASSMS IIT. I am Archana Ubale, Department of E&TC, ASSMS IIT Pune. I am going to explain that is working principle of induction motor. Actually, induction motor that works on the principle of electromagnetic induction. In three-phase induction motor, when three-phase supply is given to the three-phase stator winding of the induction motor, that generates the rotating magnetic field of constant magnitude, and speed of that rotating magnetic field is called as the synchronous speed. So over here in this diagram you can able to see the stator generates the rotating magnetic field, and that rotating magnetic field speed is called as the synchronous speed, and that is denoted by an S. The rotating magnetic field produces an effect of rotating poles around the rotor, that generate the effect of rotating poles around the rotor. The direction of rotation of this rotating magnetic field is clockwise, that you can able to see in this diagram. At that instant when rotor is in the stationary, the stator flux which generated by the rotating magnetic field, that is rotating. Obviously, there exists a relative motion between rotating magnetic field and rotor conductor, and when this rotor conductor cuts the magnetic flux, that generates the EMF, or EMF get induced in the rotor, and this is nothing but electromagnetic induction. So in this diagram you can able to see the rotor forms the closed circuit, and induced EMF circulate the current. So you can see over here in the diagram B, the induced EMF circulate the induced current in the rotor conductor, and that is called as the rotor current. The direction of current is going into the paper denoted the cross. So here conductors you can able to see here in the round. Any current carrying conductor produces its own flux. So rotor produces its own flux, that is called as the rotor flux. So in this diagram see, you can able to see over here the flux generated due to induced rotor current. Here two fluxes are present. One is the rotating magnetic field that is generated due to the stator, and another flux that is generated due to the rotor. So if these two fluxes are in the same direction, that will get added up, and that makes the high flux area. But on the other side, if two fluxes are in opposite direction, that get cancel out and produces the low flux area. So in this diagram you can able to see the cancellation of two fluxes, which is low flux area, and here addition of two fluxes, that is the high flux area. The flux line acts as a stretched rubber band. High flux density area exerts a push on rotor conductor toward low flux density area. So rotor conductor experience a force. So you can able to see over in this diagram, this rotor conductor experience the mechanical force. As rotor conductor experience the force, the overall rotor experience the torque and start rotating. So interaction of these two fluxes is very essential for the motoring action. So in this way induction motor works, or this is the principle of working of the induction motor. So ns is the speed of the rotating magnetic field and n is the speed of the rotor. But if what happen if the speed of the rotor and speed of the rotating magnetic field both are same? So when the speed of the rotating magnetic field and speed of the rotor both are same, at that time the relative motion of these both are same and the flux get cut by the rotor in this condition, that is 0. So EMF get generated in the rotor that tries to goes onwards to the 0. So when that goes to the 0, the speed of the motor is also goes to the 0. So in that condition the motor will stop. So never the speed of the rotating magnetic field equal to the speed of the rotor. So induction motor never rotate on the synchronous speed, and generally the induction motor speed of the rotor that is less than the synchronous speed for this reason. Thank you.